A body is thrown upward from ground, covers equal distances in 4th and 7 seconds. With what instant velocity was the body projected? Now, see, before we try solving the question, I'll give you the graphical representation and explanation based on that graph. Once you pay attention to the graph, any question, not just this, almost any question based on equal distances, equal time projections, that will become really easy for you if you understand this graph carefully. So, anyway, I don't have the, or else what I'll do is I'll try to include a graph paper. That would be more clear way of explaining. So, consider this to be the graph. The body here is projected. The body is projected from the ground with the initial velocity u as 30 meter per second. Okay. So, we'll have to understand the graph by taking a couple of points to make sure that we understand we analyze the motion properly. So it's like this: we take point A, point B, C, D. This is point E. This is point F, and this one G. Okay. So if we start analyzing the question, analyzing the data, what do we have? At A, at time t is equal to 0, the corresponding velocity is 30 meter per second, because the coordinate of A is 1 comma 30. So, sorry, 0 comma 30, right? So, at time t is equal to 0, the corresponding velocity is A30. When it comes to B, at time t is equal to 1, what is the corresponding velocity? The corresponding velocity is 20 meter per second. Very similarly, at C, the corresponding velocity is t is equal to 2, the corresponding velocity is 10 meter per second. D, at t is equal to 3, it is 0. At E, t is equal to 4, right? This is the point E. So this is the point. There's a minor mistake in the graph. This should actually go like this, right? Yeah. So at t is equal to 4, we have minus 10 meter per second. This would be F. So at F, t is equal to 5, and the corresponding velocity is minus 20 meter per second. We just, what we did is just we were just reading the graph. That's it. Now let us try to make sense out of it. So we can say that the motion, the total time taken, or say we'll consider time of ascent and time of descent. So the ascent is the time taken from the ground position to reach the maximum position, right? So A to B is the ascent. So the maximum velocity here was the velocity of launch, that is 30. It eventually came down to 0. So 0 velocity was seen in t is equal to 3 seconds, which means time of ascent is 3 seconds. Time of descent is also, we know that time of ascent is equal to time of descent, so that will be 3 seconds. Now let us see the pairs. See, if the total time is equal to 6 seconds, what can we say about the corresponding velocities at the respective points? We can say that time at t is equal to 0 and time is equal to, sorry, at time is equal to 3 and time is equal to 5 will have the same velocities. Time is equal to 2 and time is equal to 4 will have the same velocity. I'm sorry, not the velocity, will have the same speed. And time 3 will be the 0 velocity. So let's discuss this one more time. If the object is projected from ground at t is equal to 1, the speeds will be, so say if this is t is equal to 1, if this is t is equal to 1, the velocity here is 20 meter per second, and here also the velocity, so the speed will be 20 meter per second. But what would be the corresponding time? The time would be t is equal to 5 seconds. Now, when the body is even higher, the velocity would reduce in the ascent, which means the velocity would be 10 meter per second here, and the corresponding time will be t is equal to 2. But when the time is again 4 seconds, the speed would be the same again. So time is equal to 1, 2, 4 and 5, which means at time t is equal to 3, the body is momentarily at rest. Please re-listen to this explanation and the concept should become really clear. So if that explanation was clear to you, let us now try solving this question. So it is given that the distance covered in the 4th and the 7th second are equal, which means, which directly means that the body was at its maximum height when it was the 5th second, which means at t is equal to 5, the body was at its maximum position, and at this position the velocity was equal to 0. So we can say that v is equal to u plus at at t is equal to 5 is what we require here. So what is v is equal to? V is equal to 0. Why? Because t is equal to 5 is the maximum height is equal to u. What is u is what we have to find out. U plus what is a? A is minus g. Again, why? Body is projected upwards with velocity u. Acceleration due to gravity is minus g. Into time is given as, time is not given. We have found it as 5 seconds. So we can say that u is equal to plus 5 into g. Therefore, u is equal to 5 into 10, which is 50 meter per second. I really apologize for the wrong options given here. It is basically, it was supposed to be 10, 20, 40 and 50. So the correct option is 50 meter per second.